Hi everyone, welcome to the channel Math for me and you. Let's learn maths together. Hello dear friends, I am Sindhu. The topic of this video is domain of a function. First of all, we look what is a function. A function is a relation or rule between two variables. Usually we denote a function as y equals f of x. And the two main or important terms in a function are domain and range. Domain means all input values and range all output values. But what is domain actually? What is the meaning of domain? Consider a function y equals f of x. If we give values for x, they are input values. And such values are called domain. So all x values or set of all x values are known as domain. So what is domain? Set of all x values. And what answer we get when we put these values, they are called a range. So y values in a function are called the range or all output values, or we can say the result. In this video we are going to practice how can we find the domain of a function. And for that I have grouped the functions into three different types. First type, if y equals f of x is the function and f of x is a polynomial, what is the domain of that function? Well, if you don't know what are polynomials, please check out my video about polynomials so that you will get an idea. I can give the link in the description box. First we can start with a linear polynomial. Here I have taken y equals 2x plus 1. What values we can put for x, or what is the domain of this function? We can give negative values, positive values and 0, because if we put any value for x, we get an answer for y. That's why it is well defined for all the values from minus infinity to positive infinity. The domain, that means all the x values from minus infinity to positive infinity. In a number line, we can write x takes the values from minus infinity to positive infinity. Or we can show this with a letter. What is that? We denote this with the letter r, because r stands for the set of all real numbers. X takes all the values. Next we can consider a quadratic polynomial function. What is the meaning quadratic? Quadratic means the highest power of the variable is 2. Here I am taking 7x square minus 15x plus 8 as an example. See the function y equals 7x square minus 15x plus 8. If we give x a negative number or positive number or 0, we get an answer for y. So we can write domain is minus infinity to positive infinity, or we can write r. That means whatever the polynomial function we get without denominator, without under root term with x. Keep this in mind. Without denominator or without a root expression, if whatever the polynomial function we get, we can write the domain of such functions as minus infinity to positive infinity. Consider one more example. Here the polynomial with the highest degree 8. Here also the domain minus infinity to positive infinity. Now if we get a function with absolute value, with modulus, for example, y equals absolute value of x plus 1 modulus x plus 1, or y equals absolute value x minus 7, all these type of functions also domain is from minus infinity to positive infinity, or we can say the domain is r. These functions, they don't have any under root expression or they don't have any denominators. Next is type 2. Here we are discussing about y equals f of x. The function with f of x is a fraction. That means it has numerator part and denominator part. So we can write y is equal to, and the form numerator with the denominator, because f of x is a fraction. And in a fraction, the denominator cannot be 0. So we can say denominator not equal to 0. If the denominator equals 0 means the value of the fraction becomes undefined. We know that. So here the condition for a fraction we can take and we can make use of that to get the domain. So what is that condition? For a fraction, the denominator not equal to 0. We can write denominator not equal to 0. So please note that if we want to find the domain of a function which is in the form of a fraction, we use the condition denominator not equal to 0. We can practice this with the help of some examples. Consider a function y equals 1 over x. You can see 1 over x is a fraction. What is the condition for a fraction? The denominator not equal to 0. What is the denominator here? X. So we write that x and then put not equal to 0. Yes, this is the domain, x not equal to 0. That means x can take all the values except 0. But how can we write as an interval form? We can write that. So domain means all the x values except 0. Draw the number line and we can mark 0 in the middle. But 0 we don't take 0, that portion is open. All the negative numbers up to 0 x can take. All the positive numbers from 0 also x can take except 0. See, that part we make open. The number 0, that part is open. So what is the interval form? There are two intervals you can see. The first interval from minus infinity up to 0. Always use a simple bracket for minus infinity or positive infinity, and here for 0 also we use a simple bracket because it shows open. So it is minus infinity to 0 union 0 to infinity, or we can say r minus 0, or we can say r cut 0. See the next function, which is also in the form of fraction, 1 over x plus 2, y equals 1 over x plus 2. What is domain? How to find? This is a fraction, so we take the denominator, that is x plus 2, and write not equal to 0. Can you find the value of x? Yes, move the number to the right side. X not equal to plus 2, we can move to the other side as minus 2. See, here we get x not equal to minus 2. This is domain. But how can we write as interval? With the help of a number line, we can write the domain as an interval form. Draw the number line. And now we are putting the number minus 2 in the middle, and we open that portion, minus 2, that part is open, and x takes the values, all the negative numbers up to minus 2, and from minus 2 up to positive infinity. That means r cut the number minus 2. That means all the real numbers except minus 2, or we can write r minus minus 2. And what is the interval form? Interval form is x takes all the values from minus infinity to minus 2, both open, use simple bracket, minus infinity to minus 2, union, minus 2 to positive infinity. That side also we use open, that means simple brackets. Look at the next function, which is also a fraction. 2x plus 5 over x square minus 7x plus 12. To get the domain, what we will do? We will take the denominator, that is x square minus 7x plus 12, and write this expression not equal to 0. But this is quadratic expression. What are the factors? If we get the factors, it would be easier. So we write the factors as x minus 4 times x minus 3. If you want to practice more about factorization, you could check out my video about factorization. I can give the link in the description box. See the factors here, x minus 4 times x minus 3, write not equal to 0. Take one by one. First factor x minus 4, and then we write this is not equal to 0. Move the number minus 4 to the right side so that we get x not equal to positive 4. Same way we can find the other value. That means x minus 3 we write and write not equal to 0. From here we can write what is x not equal to. X not equal to positive 3. So we get here the x values. X can take all the values except the number 3 and 4. We could write the domain. What is domain in this question? R and cut 3 and 4. All the values except 3 and 4. Or we can write R minus set 3, 4. Next type, if we get a function y equals f of x, where f of x is with root. Under root is an expression contains x. We have practiced, we have studied that if any expression comes under root, then that expression must be greater than or equal to 0. It must be non-negative. It cannot be negative number under the root. So we will take this condition and we use it to get the domain. If we get a question with the root, we can take this condition to find out the domain. See this. This is a function y equals root of x minus 4. We are going to find the domain. So we look what is inside the root or what is the expression under root. It is x minus 4. Take that and write greater than or equal to 0. So here the function is with the root. So we take under root expression and write greater than or equal to 0. From here we write what is x. X here greater than or equal to minus 4 going to the other side as positive 4. And we use the same inequality greater than or equal to. And this is the domain. If we get one side x, then that is domain. So we can write what is domain here. It is x greater than or equal to 4. How can we show this result in a number line? Draw a number line. Here we can see the number 4. We have to mark it in the middle. Greater than or equal to means close that one. So from here 4 included. So for closed, x greater than or equal to, x in the larger side of the inequality. So x takes the larger values from 4, the larger values. So all the greater values than 4 on the right side of the number line. 4 to infinity because x takes larger values and this is closed with the 4. How to write closed interval? See the bracket. We use the square bracket. 4 to infinity. Always infinity open. Next one. Y equals square root of 9 minus x square. Same condition. This is a root function. So we look what is under root. It is 9 minus x square. Take it as and greater than or equal to 0 we have to write. Here we move minus x square to the other side. Then we get 9. Same inequality greater than or equal to x square. But x square, how can we take x? Square root. Okay, now take square root. We get x, but square root of 9, we get it is positive 3 and negative 3. So x takes two values. You can see x with the two values. We have to write down the inequality connecting with the positive 3 and negative 3. How to write this? If we connect with the positive value, we have to use the same inequality from the first condition. It is greater than or equal to. When we connect with the negative number, we have to change inequality to the opposite direction. So here we have to write less than or equal to. With the positive, we have to use the same inequality in the first power 2 condition, and with the negative, we have to change inequality. Now we can draw a number line to show the domain. Draw a number line, but here two values we can see. Always the small value on the left side, that is negative number, we put on the left side of the number line, and to the right side we mark positive value. And now we can start with x and plus 3. See plus 3, the inequality with equal sign, so we have to close the number. And then we look where x in the smaller side of the inequality. It is not in the open side. You can see x with the smaller side. That means x takes smaller values than 3. We have to mark the numbers to the left side because smaller values always to the left side of the number line. But when we get or when we reach minus 3, stop. Now we have to move to minus 3. With the minus 3 also we have to close because of equal sign. And now look at x. X in the larger side of the inequality, open side. That means x takes from minus 3 larger values up to positive 3. Now look at the number line. X takes from where to where the values? X takes from minus 3 to 3. Both minus 3 and 3 closed. So we have to use closed bracket, that means square bracket. The domain of this function is closed interval minus 3 to 3. Next function y equals square root of x square minus 36. We take the under root expression x square minus 36 and what we write is greater than or equal to 0. First we find x square. How? We move minus 36 to the other side of the inequality. X square greater than or equal to positive 36. How to get the value of x? Take the square root. X, when we take the square root, we get two values, positive 6 and negative 6. connect to positive value using the same inequality in the power 2 expression. That means with the positive we connect greater than or equal to. With the negative we have to change inequality to the opposite direction. X less than or equal to minus x. This is the domain, but we have to show it in the number line to get the interval form. Draw the number line and we can see two values we have got here, plus 6 minus 6. Negative value on the left side and positive value we mark on the right side. If we start with positive 6, we can see the inequality with equal sign. So we have to close. Okay, we are going to take x greater than or equal to positive 6. So please, we can close that one. And now we look, where is x? With the inequality x in the larger side, open side of the inequality, x takes larger values from 6 up to positive infinity. X takes the values from 6 to infinity. Then we are going to the next inequality, that is with the negative 6. Negative 6 also you can see the inequality with equal sign. We close. After that we look, where is x? With the inequality x in the smaller side. That means x takes the smaller values than minus 6. From minus 6 towards the negative side up to minus infinity. Now how can we write this interval? We can start from left to right. So we have to write minus infinity to minus 6 and minus 6 closed. Union from 6 to positive infinity, 6 closed. Both negative infinity and positive infinity, that side we have to use simple brackets to show both they are open. Okay, next with the root there is another type of question we may get. If the root in the denominator side, if a function in the fraction form with the root in the denominator side, then what we will do? If it is a fraction, we have to consider the condition denominator not equal to 0. And with the root we have studied another condition, that under root expression must be greater than or equal to 0. But if it is in the denominator side, we have to join these two and then we have to write the expression which comes under root must be greater than 0, because not equal to 0 means we cannot write here equal, just write expression greater than 0. See, if we get a root expression in the denominator, that time we write expression just greater than 0, because the denominator cannot be equal 0. Look at this function, y equals 3 over root of x plus 2. Here the denominator you can see that cannot be 0, not equal to 0, but the root is in the denominator. So we write what is under root x plus 2 and write greater than 0. If we have root, we usually write greater than or equal to, but here we cannot because it is in the denominator side. Then what is x? X greater than minus 2. This is domain. But how can we show it using an interval form? Using a number line. We will draw a number line and we can see here the number minus 2. We mark that number in the middle, and with minus 2 we need to open the circle because only greater than, no equal sign. That's why. And finish minus 2. Look at x. X is greater than or less than, x larger. It is in the open side. So x takes the values, larger values up to positive infinity. So the interval we write open interval from minus 2 up to positive infinity. See, this is a different type of function. Here we get root in the denominator side. So we take that under root expression, just write greater than 0. Now it's time for the practice questions. If you have any doubt while answering the questions, please comment under my video so that I could give you the corresponding answers. If you like this video, please share and subscribe to my channel. See you with more useful videos. Thank you.